Cool. All right. I'm Max. As you know, I'm a production support engineer at Invoca. It's a cool place to work. There's my GitHub, and I'm a Padawan programmer. I've only been programming for like 2 years. It is awesome, and I love it, and yeah, cool stuff. All right, so really like the question that when I learned about these kind of like higher level hardware programming languages and or just kind of like libraries like bonescript or cylon or Johnny 5, I kind of was like, well, there's already C++, so why? You know, it's good at what it does. So like, why would you extend it? And it's really just like, why not? I mean, it's like the same thing can be applied to like, you know, creating any languages. It's like, you know, C did really well. Why did we create any other languages after that? You know, and it's just because, yeah, why not? Things are, you know, good at doing other things, and should just make more languages and make more ways to approach the same problem. And, you know, you get kind of really cool stuff where you basically, like with Cylon, you get all these free APIs where you can just, you know, define devices, and then you have an API that you didn't even write, and it just, you're able to hit it and, you know, interact with all your devices, and it's really cool. But, you know, as you know, like we got Google made V8, which was a C++ compiler for JavaScript, and we got Node, and then we get all these things that you would normally be able to do in C++ in JavaScript. So that's pretty cool. So you get the ability to have all these, well, I guess you get also the advent of all these microcomputers, like the Raspberry Pi and the Beaglebone Black and stuff like that, where you have a Linux operating system that can run a JavaScript interpreter, but you also get all this access to GPIO, or general purpose in and out. And that basically just allows you to control hardware devices using a Linux file structure, which is pretty cool. A little different than if you did something with Arduino. But yeah, it works. So, and it's cool when you get to write, you know, hardware stuff and web stuff all in JavaScript, which is kind of cool. But basically that's the Beaglebone, Johnny 5, Cylon, the Raspberry Pi, and they're all kind of coming together. I picked Cylon.js just because it seemed to work really well. It's still, all these are still pretty nascent, and the communities are, you know, I think the Raspberry Pi is probably the largest community. Johnny 5 is a little sparse. Cylon's a little bit better, but their documentation still kind of sucks. And the Beaglebone is kind of like subsided out. It was kind of a successor back when Raspberry Pi was still version 1, but not so much anymore. What are they? So they're these little like credit card sized computers. Basically Beaglebone is just like a Raspberry Pi credit card sized computer with a small Cortex chip, just like your phone has, which has also a bunch of GPIO or... it's not like a software. No. Yeah, so you have your 2 hardware and your 2 software, and they come together to extend JavaScript to real things. Yeah. And then why robots? Because they're freaking cool. And like, that's what everybody's doing right now. Yeah, I mean, like, you know, Terminator, RoboCop, you know, like the Terminator, the like silver guy, that guy's awesome. So yeah, I mean, like, I'm not worried about neural networks and Cyberdyne and all that kind of stuff. I think that's pretty cool. You know, but so I went to Maker Faire last year, and like, there's one you should go if you can. It's like, I mean, if you go with us at the Hackerspace, we'll get you in for free. So totally recommend that. But it's like $30 for the whole weekend, and you get to see a bunch of really cool stuff. And speaking of cool stuff, I saw this one really cool robot after an ad place. But basically, yeah, there are a lot of really cool robots, and this one was the one that that caught my eye, was that it has a lot more. Oh, um, let me skip. Oh. So basically what this is that it's a, like, you know, a kind of like, not a quadruped, a sexped, I don't know. But it's a, like, kind of like a spider robot, but it also has roller skates, which is just crazy. And basically, like, the really cool thing about robots is that, sure, you get to like control all of these little hardware bits, like servos and motors and stuff like that. But as you can see with all these movements, that's called kinematics, and it's really crazy. Basically, like, since you have all these joints, you're kind of like, basically what you're saying is you're telling the robot, hey, I want this wheel to go here in the range that it can go. You give it a position, but then you have a calculation that calculates all the servo angles to make that happen. And then you can also add a bunch of parameters that say, like, you can do this fast, slow, medium, however you want, or come back, whatever. And those calculations are way beyond me, but I definitely want to get into that. But it's really cool. And, you know, you can make, like, yeah, like, you can make these robots. There's a snake robot earlier, or kind of ahead, you know, and stuff like that. And it's just, I don't know, I was blown away by this. This and like animatronics is just some pretty cool stuff. But yeah, see, snake robot, but yeah. Like, I don't know, I thought the roller skate one was a lot cooler, but basically robots are high stakes Legos. Like, I remember I tried to get into erector sets when I was younger, and it was just really complicated and hard, and I didn't really understand it. And I'm glad I have a way to get back into that now, where I probably have a little bit more patience. And also, you know, or if you ever played with Lego Mindstorms, or wanted to play with them, you know, we live in such a cool time where you can spend like $40 or $50 and get a bunch of servos, get a bunch of Raspberry Pis or whatever, an Arduino, or some knockoff Arduino. You can get like 5 knockoff Arduinos for $50. And you could just do so many things because you're not limited to what used to be probably just proprietary hardware. And there are also just so many guides. Like, you know, oh, I want to get a temperature sensor, type that in, temperature sensor Arduino, it's there. Like, it's really hard to not find some tutorial about something, and then you can just piece all these parts together to make something your own, which is really fun. And then also, you know, now you can curse in really creative ways when things break instead of when you were 5. So it's really fun even when you break stuff. And then, yeah, there's a lot of new things to learn. Like electronics, they're really scary. Like, you can, you know, shock yourself. You know, you can like burn a lot of, you can waste a lot of money by burning chips and stuff like that. And then there's kinematics. You can, you know, blow your brains out with math, and make really cool things happen, like skating robots and snake robots and stuff like that. Computer vision. You can, you know, add any type of machine learning you can shake a stick at and make these robots, you know, like, yeah, it's endless. And then working with physical things for a change. I mean, we all stare at screens all day long. Like, it's really cool to have the ability to do a little programming and do some stuff that you're pretty familiar with, or, you know, build something that could, you know, make your work or whatever the hobby that you do now in your life better, but also get to do something with your hands. You know, like, you could laser cut, you could 3D print, you could, you know, whittle it all out of wood if you really wanted to. You can do a lot of stuff, but yeah, just working with your hands for a change is really fun, and actually writing software to do something that happens in the physical world is really cool. So yeah, like it's kind of like carpentry, but then it moves, and that's kind of cool. You can also not do it in wood too. I'd actually recommend that, but that's for another time. So basically, like, how did I get started, or how do I get started? Basically, how I got started was just going on the internet. There are a lot of websites like Thingiverse, Adafruit, Make, that just have all these different projects that you can work on. But basically, you'll need a microcomputer or microcontroller. So basically what the difference is that a microcomputer like a Raspberry Pi has a full operating system on it. It works, just like your computer does, where you do stuff, then the kernel says, hey, actually, I have to do stuff now. Then you wait, and then it does stuff, and you kind of flip-flop back and forth in what are called like interrupts. But then you have microcontrollers where you can actually say, no, kernel, you can't do anything. I'm running entirely until I finish, and then you can do whatever you want. So the difference between those is that microcontrollers like the Arduino, where you get that kind of ability to do I guess all the work in front of you, and get to really control the time, is really good for time-sensitive stuff. Like where you're like for instance, like airbags and stuff like that. You wouldn't want like the thing that's doing your media player to go, hey, I'm actually using the CPU right now, before you figure out that we're in a crash right now and you have to deploy the airbag. It's like, no, I'm higher precedent than you are. So that's what a microcontroller would be really good for. Whereas a microcomputer, you get all this ability to have like a server, a bunch of files, kind of like write code on it, SSH into it, play around with it, stuff like that. But at the, I guess like at the loss of the time sensitivity, you do get some of that back. Like the Raspberry Pi has some pins that are hardware accelerated, basically. So you get a little bit of performance, but at the same time, it's never the same. And then you need a bunch of soldery kits and electric-y stuff, like, a voltmeter would be a really good idea, breadboards for like prototyping. I think like you probably shouldn't do soldering for like your first year, because you'll have too many things in your head and you'll want to reuse parts and stuff like that. But you can if you want. And then just find an idea for a first project. But again, you can also just skip all that and buy a kit. Don't ever let anyone say that you shouldn't buy a kit, because they're stupid. Like it works, and like it all works, and it's supposed to work together. And if it doesn't work together, you leave a really shitty review. Like, I mean, like you can't do that if you're like piecing all these parts together, because then it's like it doesn't work. It's like, well, I could have told you that because you didn't do your research, and it's like, you don't have to do that. So totally buy kits if that's what you want to do. Like, you really want that like easy win to get into it. I think a kit's a really good idea. I did the opposite, and it was hard, but it was fun. So yeah, it's how much time you want to spend and how much patience you have. Depends on what route you take, but you'll always end up on this route because it's probably the most fun. So like, where do I buy all these things? Radio Shack? No. Like, you can buy servos at Radio Shack, you can buy sensors at Radio Shack, but I would say like Radio Shack is your emergency. Like, oh, I need a button, or like, oh, I need a resistor that I don't have. Because like, for instance, if I wanted to get a servo from Radio Shack, it'd be $12 and it would be terrible. Whereas I can go get like, I think like 6 or 7 or 8 on Amazon, and they're pretty good quality for $12. So they're kind of like with anything electronics, there's kind of like a hierarchy of like skill level. like how opaque the website is. DigiKey, by far the most opaque. It's filled with like spec sheets and like, it's really hard to search for you're like, oh, relays, and it'll be like, here's 100 relays, and you'll have to read through all the spec sheets for them, and it's like, ugh, okay. So then there's Adafruit and Make. Adafruit is probably the most bunny slope of electronics. It's amazing. They have reviews for everything. It's really well curated. They have projects, and then they have links to all of the items in the project in their shop and stuff like that. It's great. And then they make a lot of cool kind of like add-ons for Raspberry Pis and Arduinos to make like wearables and stuff like that. So I think Adafruit's like definitely like one-stop shop, and probably the first place you should go if you want to get into this. And then Make is another cool place that's mostly just projects. They're kind of the Maker Faire sponsor people that kind of set all that up. And then there's SparkFun and Element 14. They are usually like just board designers. SparkFun does have some like accessories and electronics and stuff, but Element 14 is pretty much exclusively a board designer. So like you'll be buying your Raspberry Pi or your Beaglebone from Element 14. Usually it's best to buy direct because a lot of people, just based on like the popularity of all these devices, will try to rip you off on the MSRP and stuff. So you'll see like, Raspberry Pis for like $60 with all this extra stuff that you don't need, where you can just go buy them for like $30, $20. And that's a lot better, especially the Raspberry Pi Zeros. They were really popular, and they're supposed to be $5, but people were selling them for like $30.
The only way to get them.
Yeah, exactly. But you wait a little while, and then you buy 6. So yeah, I would definitely recommend kind of waiting or going through all these, and definitely go to Adafruit first. And then Amazon is good too, but just be wary that, again, it's not really well curated, so you will have to read those reviews pretty diligently, especially if you're worried about compatibility. Especially with like stuff with Raspberry Pis, like let's say you had a 2 and you wanted to put a Wi-Fi dongle on it. You're best to like really do your research well before you try to pull something on Amazon, because it probably won't work. Definitely better to go with something that's like from Adafruit and totally bulletproof, going to work with your weird version of Linux. So I did my laser cutting for this project at the SP Hackerspace. I love it. It is awesome. We have a lot of cool stuff that would help in all this electronic-y, makey kind of stuff that you wouldn't have to buy. There's a membership fee, but you can, from like $5 up until infinity, and it gets you all the same stuff. So it doesn't really matter. We're up in Goleta. It's awesome. I would definitely go.
You can try it out without a membership.
Yep. Yeah. On Saturdays, it's public days.
It will help you.
Yep. A lot of smart people. I don't know anything about anything, and I just talk to people there and help me out. So yeah, I'd totally recommend it. And we have electron microscope, for whatever reason you want to use that. Yeah, and a high pressure, like the thing that splits molecules. I don't know. It's too much stuff and really fun stuff to just play around with. So yeah, there's my plug for the hackerspace because it's cool. So what did I do? There's a lot of like, what did other people do and stuff like that. I basically was looking at this one library, cylon.js, which they have a few other ports, one for Ruby and one for Go, R2, and I think like GoBot or something. And they're just basically wrappers around a lot of really cool, easy ways to make kind of like define devices, define connections to other devices, or like, other computers. Like let's say you have like a cluster of, maybe your thing needs like 10 servos. You're probably not going to all drive those from one device. You're probably going to have like, split them out into kind of these like clusters of devices. Really great way to kind of organize those things and define them. And then you get a really cool free API for either HTTP or sockets IO. And then there's also like MQPP, which is this like Internet of Things protocol, but I have no idea what it was. So I didn't look into it. And I did like building stuff, and it was like Zigbee and Z-Wave, and I don't like protocols except for like HTTP and socket IO. So I was happy to just know those and use those. Whoops. And then I tried to find a simple beginner, robotics project. So I picked this thing called the MeArm, which I'll talk about later. But there are like basically you search like beginners robotics. There's a lot of stuff out there. So I would totally recommend that. Just searching around, going to places like Thingiverse where you get all the building plans, or Instructables is a really cool place too. Or Adafruit and places like that. Yeah. So here's cylon.js. Basically, it's software running on the Linux OS. It's a JavaScript library. The docs are pretty terrible, but you can kind of parse through them, especially if you're doing kind of less standard stuff. But the drivers are really good. They have a support for a lot of platforms like their Arduino, the Tesla 2, the Raspberry Pi, the Beaglebone, Sphero, Parrot drone. Basically almost anything you can think of, which is really cool. The ability to port a lot of that information between devices is also possible. So that's not really possible between well, I guess it kind of is for C projects, but maybe not so much. It's not as easy as it is for here. And then, yeah, you have a lot of these built-in API plugins, so you can define your devices and get access to them without having to write any extra code. So that's really cool. Yeah, so the cons that I ran into with cylon.js it were basically the docs, and then the software running on the OS just makes some control a little bit jittery. That's just because of the interrupts when you're running on a microcomputer versus a microcontroller. Forms of better support, like when I was looking at the Beaglebone, which I said kind of tailed off in its popularity, its library hadn't been updated for about 2 years. And I spent probably upwards of like 4 hours doing a lot of node debugging to try to figure out why it wasn't working. I wouldn't recommend that. I would, if you're going to play around with Cylon, I'd probably do a Raspberry Pi or the Arduino or the Tesla 2, just because they seem like they have a lot bigger of a community and they support all the newer, versions of firmware or the Debian or Linux kernels that are running on those devices. So it'll make your life way easier. So basically, I did a lot of servo control. So these are just like the differences between running a servo in Arduino versus Raspberry Pi, just to kind of show you that sure, you get a lot of benefits on the Raspberry Pi side, but you do have a lot of weird trade-offs. So you have to set up your Linux environment. You're going to install this thing called Pi Blaster. So basically servos work over this, it's not a protocol, it's just, it's kind of it's like making digital signals analog. It's called PWM, or pulse width modulation. It basically just means my digital signal is going to be on or off, or 0 or 3.3 volts or 5 volts, depending on my logic. But let's say I want to change the brightness on an LED with that pin. I'm going to actually just kind of turn off and on really quickly, and the average of turning off and on, if I do it at a 50% duty cycle, that means I get 50% of the voltage technically. So then I'll get 50% of the brightness. So that's how you basically manipulate a servo is you give it these different duty cycles, and that actually sets the position or the angle of the servo. So you have to set up stuff to be able to do that. You have to install your node modules, then change the ownership of the files that are actually have the values of all these pins, so that you can write and read from them. And then you probably have to reinstall your Linux OS because you probably broke something. And then you have to copy your files over from your development computer because, I don't know, I like Vim, it's okay, but I don't like to code all the time in it. So, because you're SSHing into these machines, so you don't get to use your fancy text editor. But, you know, it's not too bad. But install what?
Install
Samba?
Samba.
Ah.
It's a network file system.
Huh. Well.
Like Let's Linux mount Windows service directories and stuff.
Oh, that's good.
Yeah, I mean, what are the changes actually? How your Linux, it's like a drive you can track it in.
Huh.
Put up in Sublime other files.
I guess you could probably do that with just like regular like network disks in Mac or something.
Well, you can mount with Mac. Depends on how you're using it. For the Linux, you can mount any file system you want to and use a network file. So it depends on your virtualization. Are you working hardware, which are again,
Makes
but
sense.
as far as SSH or SFTP, you just go ahead and mount and drag back.
Huh. Well, I'm not a smart man, as Forrest Gump said, so you know I'll look at that. But yeah, right. But on the other side with Arduino, it's pretty simple. You install the Arduino IDE, you write some code, and you include the servo header, and then you connect the servo to the Arduino, and you flash the code, and it runs. I guess like the differences between the two code are pretty similar. Like it's not that much different. You'll see this a lot more as I show my other things, but this is the Node version. This is the C++ or Arduino flavored C++ version. But in Cylon, you get this robot object, and you create or kind of define this robot object. You define your adapters, which are the platforms that you're running it on, your devices, the things that are connected to these adapters. And then you have these functions, and this work function is your main loop. So when you define this and you run this, it'll just run this continuously. You can also define functions, and then above, like if you're using the API, you can define functions and then return them, and these will be like publicly available API functions. Or you can just define functions like you are in work, but just in a different namespace. And you can call upon those in all your different actual publicly defined functions. But you can see that there's not too much more setup, but there's a lot more setup on the system side than there is if you were doing it in Arduino. So that's why this is kind of tried and true, but there's definitely a lot of benefit that you're not seeing, at least not yet, when it comes to Cylon.
What does console log do?
Console log is just the Node version of like standard out kind of.
But like on a robot.
It will. So I'm running it from a you're just running it as a like you would run a Ruby script or a Python script. So as it's getting to these functions, it's just logging that out to your standard out. Your terminal session on the SSH Raspberry Pi. Yeah. For debugging or to tell you that it's actually working, which is really, really helpful. Here's all the web languages and scripting languages and stuff like that of this hello world, and it's, you know, just prints hello world out to the standard out, maybe do some like, you know, optional variables or some, or optional parameters or something like that. But in the hardware world, no, we don't do, like, there's, I mean, besides the standard out to your console, there's not really that. It's blinking an LED is this, you know, kind of version of that. So, here's the code that we're going to run. But, you know, same deal. We're just going to define an LED at pin 36. And then every second, we're going to toggle our LED. Pretty simple.
I'm sorry, like the my argument is that, you know, it has to be my, or?
Huh?
On the word function, the my argument.
Yeah.
Is that?
It doesn't have to be my, but you are passing in my to get access to the devices and the other things connected to, I guess, like your robot, that robot instance.
Right.
So for instance, if I was defining another function called like set angle and, or like, you know, calculate angle or something, I could just pass it in like an XYZ and then just return something and, you know, use that elsewhere. I wouldn't have to pass in my. I just pass in my because I'm using the devices.
So you could use like an anonymous function to just do whatever.
Sure. Yeah.
Well, that function might just be the instance of the object that's doing the work.
Right. But yeah, it is basically an anonymous function. Yeah. Right. It is. Yeah.
Like this.
It is. Yeah. So I'm SSH into my Raspberry Pi. I'm going to run. You need sudo because you need access to the reading and writing of the GPIO files. So I'm going to run that. And there we go. Now I'm blinking this LED.
Magic.
Dude, and that's the end. So, yeah.
How are you connected to that thing? Word.
How am I connected?
Yes.
It is Wi-Fi. Ooh. Ooh. The way of the future.
One step away from Skynet.
Yeah, literally though. I mean, you know, you could plug this into a little battery, and then it's fully wireless. I didn't do that though. So then there is, I have to check if it's on, but I just wanted to show how easy it is to have this set up to a API. So I think I have that. Whoops. No. I think that's good. After Raspberry, yeah, I think this will be fine. Why don't I have my keyboard light on? So I'm going to, oops. Net LED. Cool. So I'm actually tethered with my phone to my Raspberry Pi, and that's just because I know what the assigned IP address was. I didn't want to like do it to this and like go nmap crazy to try to figure out, like, you know, just pinging printers and all sorts of stuff to figure out what the Raspberry Pi was, and, you know, all the other connected devices on the LAN. So yeah, unfortunately, unless you guys know the password to light squared, nope. So, sorry for the brightness. All right, so they give you this cool little API interface, which, where's my mouse? And you have my LED robot, and I can see all my devices. I can click my LED, and I get the different functions that I can have. I can toggle the LED on and off. I can check if it's on, and that for some reason doesn't do anything. So you can submit an issue for that, and then you get your first GitHub issue. That's pretty cool. You can also turn it on, but now it's still on. Stuff like that. I also have no idea why you say current brightness, and it says 0, and then you turn it on, and then you run, and then you say current brightness, and then it's still 0. So there's another issue. Yeah, the great thing about these things is, or like these kind of nascent libraries, is that there's a lot to go on. Like you can contribute really easily. I mean, like this is like not rocket science. So jump in there.
That's React, right?
What?
That is React. That reveal, like that thing.
It is?
I think it is.
Huh. Okay. Well, do I have the? Whoops. I think I have the React toolkit. Or do I? No, I don't. Oh yeah, I do. Is it? Yeah. You're right. I think so. Yeah. Huh. Does that necessarily mean it's React? Just because it loaded?
No, I mean, I just like went to the repo.
Oh, okay, cool. All right. So you get this cool free API with a lot of the devices that you define. Where's my mouse? Cool.
There's a great extension for Chrome called Wappleizer that'll tell you everything your page is built with.
Oh,
It's cool.
nice. Wappleizer.
Wappleizer.
Okay. Yeah, that was the Hello World. And then, working with servos, I talked a lot about that, like, about PWM and probably way too much about that kind of stuff. But basically, like, servos are just these cool little motors that are, high torque, but you can program their position. You can get continuous or non-continuous, meaning like some that only go have a certain degree limit, and then others that can keep fully rotating, and you can still get the position and stuff like that. Various sizes and torques, and some are plastic gear, metal gear, basically for anything you could ever want. And the cool thing is that when you set a position, it'll keep it while it's under power, and it'll hold that position, obviously until it gives out because it can't apply enough torque. And they basically, basically you have to give it they have varying degrees of voltages. So some you'll probably need to drive with an external power supply, like a battery, a bunch of batteries or something like that. Like the ones that I'm running are 6 volt. That's where you get their max torque. You can't do 6 volt from a logic board. Usually, as I said, they're 3.3 or 5 volts. So if I were to try to drive something with 6 volts, it probably just wouldn't work as well. Also, I probably don't want something that's 6 volts on the same circuit because I don't want to risk blowing something out. And then that goes up for things that are 1500, whatever voltage and current and stuff like that. And then you get into using these things called MOSFETs and relays, which are basically ways to kind of quarantine your logic and like your delicate I guess your delicate computer parts from the things that are running high voltage. And those are really cool. But we'll talk about those another time. And what are they good for? You probably had servos in your electric car. Like basically, if your thing was RC, it had servos, like steering, planes, stuff like that. That's what they're really great for. And then this is just a simple way to define a servo. So you have to just like you were doing with the LED, you have to require your cylon library, say that you're using the Raspbian connector or Raspberry Pi connector, but then you say, hey, this is a servo at this pin, but you have to tell it a frequency, which is basically the PWM frequency, and then you give it like and basically where do you find this information? There is a servo data sheet. It's just a website. It's called, like, if you type like servo data sheets, it just has literally every servo except for the Radio Shack one. Like totally, there's a whole, that tells you that you shouldn't be buying servos at Radio Shack. So yeah, don't do that, especially because you won't have any idea what to set these to, and you'll burn out your $12 Radio Shack servo. And then you just, set the angle, and it does what it does. So that's how you do servos. And just a little bit more about how they work. As I was saying, if it's a square wave, you send it a square wave of, on and off. And the more time that is on, the different, basically, the different amounts of being on set the angle of the servo. And as I just said, servos usually require higher voltage, so you'll probably have to quarantine it off. And they also need to be calibrated, which sucks, because you have to figure out some way, unless you have I have a bunch of RC planes, so I have a lot of stuff to like center my servos, but you might not have that ability, it can just, it's not really make or break, but it's just annoying to have like a servo that's like slightly centered, but not that centered, and then it's never really that right. It's nice to just have something that can do that. But again, they're like, you can get specific servo centering, like potentiometers for like, I don't know, like $10, $15 or something like that. Not a big deal. So I'm going to actually demo my little robot before I talk about expectations and reality. I think we're pretty much good. Let me turn on the light. Where would I do that? Maybe? Right by me? Oh, yeah. I don't know. I don't know. It depends. That's good? Okay. Cool. So, oh, what? Open up one of these again. Cool. All right, so as you can see, I'm not much of a UX guy. Ship it, right? This is, I guess I'll show you the code first. But it's very simple, which is really cool about Cylon, is that I actually don't actually use this, but all I did was define a bunch of servos. That's it. And then I just said that I was going to create a socket IO API and just pass in, a host and a port. and then just said it was going to be called the me arm because that was the project that I was working on. But that was it. Like, that's all. And then I, did some crappy JavaScript to basically, make a bunch of range inputs, and then open a bunch of sockets to this URL. And then, I had to find a way to basically anytime I change the socket, so I just put an event listener. I'm sure there are way better ways to do this, but and then just find which socket corresponds to which input, and based on the ID and stuff like that, and then just set the angle. So no big deal. So then. I don't even know where I am right now.
Did you try it all doing it with one socket?
Yeah, so that's where it gets to the point where it's like, I don't really know, there weren't that many, so like I know with sockets, you get a thing called a namespace. And you basically, it's like a hierarchy into, whatever, and you can emit to that and, create, put like on, event listeners and stuff like that on these different sockets. But there isn't that much documentation on how any of these sockets are set up. Yeah, for cylon, it's basically like you can open a socket to this device. But it's like, what happens if I have like 6 devices? And they're like, well, I don't know, shit out of luck. And it's like, okay, so do I open up 6 sockets? Like, I think that's the limit of my browser. Like, I think you can only have 6 sockets on a Chrome browser. So it's like, okay, well, then what happens if I have more than 8 devices? Well, then you're out of luck. So definitely play more around with this, but where's my mouse? Okay. Oops. So this is kind of like where kinematics comes in, where certain things can probably should be moving together, but I'm like just stalling out the servos. So there's like the claw. I've limited these so that I don't blow my servos. They probably could like move more than they should. Let me see if I can get it actually to move a little bit better. There's like a good combination of like things. Oh boy. Yeah, there you go. Yeah, so it doesn't really sound that happy, but whatever. Yeah. So there's the thing and it moves. That's yeah. That's it. No, yeah. So that is using sockets. There's probably better ways to utilize those sockets. Like one thing that I really wanted to do, but I just didn't have time to, because I like to do my things last minute, was be able to just like drag and kind of have like a binding. But I'll look into that. I thought that'd be pretty cool. And then also just probably recut this in a more frictionless material, also one that's not warped like crazy. Laser cutting like really warps wood, especially if you have the power on way too high like I did. Yeah, so acrylic would be a good idea. You can actually do like thin metal too, depending on like what power your laser is. But at the hackerspace, we can do like cedar or ply like this, or MDF. Actually, MDF was way better than this, but I just couldn't find 3mm MDF. Yeah, so there's that. Oops. Yeah. So, just like expectations versus reality. Like, you know, I'd go into your first robot project thinking that you're, you know, definitely pick something that is pretty low because you want that easy win. I would say that this was like on the cusp, just because it was like really small parts. And also laser cutting and like SVGs are like scaling vector graphics. It's like the way to kind of like cut out things and create like paths to be cut out. But those are just totally not my wheelhouse. So a lot of these things were just not my wheelhouse, which is good. You should be doing stuff like that. But maybe like one thing not in your wheelhouse, not like 8 things in your wheelhouse, not in your wheelhouse. So, you know, I would even want to make a robot like this, but I just think it's really funny.
What is your purpose?
That's what.
Yeah, so robots. Yeah, I mean, like you think, I wouldn't even think that you're going to go into it thinking that you're going to, you know, build the next, you know, SpaceX rocket lander. Like that's just like, why? You should be building this. It's because it's crazy and it's cool and it plays the flute 21st century fire. So yeah, I think that you should go try to build. Well, I don't think you should do anything. I can't tell you what to do, but I would. I want to convince everybody to at least try to do some kind of like maker thing, because you know, I mean, we live in that time where you can go buy all these, you know, devices and all this equipment for a really reasonable price. And then also it's really accessible. Like you don't have to do this in school anymore. You don't have to, you know, be on an education finance or like an education budget to get robotics anymore. Like it just, or yeah, it's not, or it's just not up to like industry. Like you can get consumer grade robotics. It's awesome. So yeah, I would say that you should go for it and, you know, probably pick something that's like relatively easy, or if you think you're gonna just kick ass, just go for it and do something crazy. Like I want to do a quadruped next time. That's like the spider thing. So yeah, definitely just go for it.
Simone Giertz.
Is she the queen of robotics or something?
The shitty robot?
Yeah, the shitty robot girl. Yeah. She's really cool. But like, you know, we could probably pull up a YouTube of that later, or you know, I don't think I have that many slides.
The breakfast machine is really short.
But yeah, that's a quadruped. But yeah, she does like just like a hand on a spinning thing, just hits you in the face to wake you up, like you know, just like stuff like that. And that's all. Like, it's kind of like if when someone like goes to you and like they're like, oh, like you know, why are you wearing this clothing? It looks so crazy and it's all like not socially acceptable. It's like, well, what are you, the robot police? Like, you know, I can build whatever I want. Like, doesn't have to have form or function. But this is kinematics. It's pretty crazy. Like, so you have all your joints and you basically are like creating the mathematics for like all the angles of when something is at all of its angles, when something's at all of its angles, when something that it's like what? But yeah, this is the robot that I want to make next. It seems like you could do some computer vision stuff because it can walk around and stuff. But I would also like to do more stuff with the claw, especially with like, it'd be cool to be able to tell it to go to a certain position out in front of it, do some like light kinematics kind of stuff. But yeah, next steps for me are, kinematics, more complex robots with more servos and sensors. Probably get into, lower level stuff like, Arduino and C++ kind of stuff. But I definitely want to contribute to Cylon just because it seems pretty easy. It seems pretty low bar. And if anybody wants to jam with me and, do some of that, that'd be really fun. I love contributing in open source. So, if you want to get into that, let me know. And then maybe buy a Tesla because you said that they, compile JavaScript to Lua, and that's really cool.
No, not anymore.
Not anymore?
So the Tesla 1 did that.
Yeah.
Now, Espruino still does that.
Okay.
So Espruino is sort of like an Arduino class device.
Yeah.
Compared to Raspberry Pi. Really beautiful startup. Like I got it, the Espruino Nano. Plugged it in, I had a JavaScript console on my serial port.
Yeah.
So it was really easy with GKO, blah, blah, blah. But the Tesla 2 is running Linux on OpenR WRT.
Okay.
So it has built-in Wi-Fi, boom, it's a router access point. And I just used it for a project. It's really great. But the older Tesla 1 used the Lua interpreter.
Okay.
And the newer one doesn't.
Well, then there you go.
Just keep going. Just in case.
And
But their technical support was great. Like I was using it for blinky LEDs.
Yeah.
And there's a library called Node Canvas, which lets you use the HTML5 Canvas interface in Node. But it depends on a library called Cairo, which they haven't dealt with porting it to that OpenWRT. So I asked for some help, and within an hour, 3 different people were helping me solve that problem.
Wow, cool.
We haven't got it solved yet, but but they did attempt to install
In
the library
progress.
in the build kit. They said, "Oh, I have to use these dependencies. Oh, we need to fix it that way." So they had a couple of iterations in trying to fix it. So
Cool.
It felt very collegial, very friendly.
Nice. Yeah. I feel like the JavaScript community is pretty great, so I think hopefully, solve your problems.
So on the Raspberry Pi, it's running, Node's running on the device. On the Pi.
Yep.
But if you use it with Arduino,
You're running it from a host
your
machine.
computer and you're just talking.
Exactly. You're basically doing like RPC. So you actually, I don't know if it was for Cylon, but I know for Johnny 5, you actually had to load a specific like firmware. Firmata onto Arduino, and then that's how they talk. That's how you talk from your host machine to the Arduino.
So that's basically a hardware breakout at that point.
Yeah, exactly. And honestly, for what it's worth, the majority of people doing physical programming or hardware programming on Raspberry Pis or Beaglebones or whatever are using breakout boards anyways. You just a lot of people are using like I2C, a lot of I2C bridging and stuff like that. But there's no reason why you can't do something like this, or even probably something like this, where you don't really care how fast these servos are being manipulated, and you can just use the software GPIO. I'm pretty easy to please. Like, I think when I just had the claw move like an inch, I was stoked. I mean, it depends on where your bar is, but my bar is pretty low. I'll put these slides up so you can actually click these links and they mean anything to you. But basically, I did this thing called the Me Arm, and this is version 1.0. There are a bunch of other versions, and then the library I used was cylon.js. Cool. Thanks, guys. talked already
So
too much?
what we normally use, if you weren't like using JavaScript, or like, let's say Arduino.
Oh, if you were doing Arduino, you'd use C++ or Arduino flavored C++. That's what everybody uses.
Or if you could be tethered to your device.
Yep.
Fermata
Yep.
processing.
Yep.
For example, can let you do some really interesting stuff. So you can start using more interesting front-end tools if you have this Fermata serial link to control your device.
Yep.
So it's as an architecture that'll work for you because you have a PC that'll be connected.
Right. But C++ is usually.
Well, no, you'll be programming, say, processing, or you can program Go, or you can program in whatever you want, because it's just a PC
Right.
that you're programming. What's on your Arduino is just this shim Fermata that exposes sort of an API to all the pins.
But if you were actually flashing software to the Arduino, that would, yes, be in C++. And there are other boards like the, I think it's like the Nucleo, which is, so there's a standard now for these kind of like Arduino flavored C++ embedded devices called Mbed. There's stuff called like the STM Neutrino or the STM32 Neutrino, or Nucleo, sorry. And then there's, the Arduino, and there's like a bunch of other AT-Mega, like the Arduino Uno is an AT-Mega. And yeah, Teensy. I think,
The trinket,
yeah, the Teensy and the Trinket, and then there's like the Leap Spring or something. I don't know. Yeah, there are a bunch of them. All in varying sizes, with some have their own sensors on them and stuff like that, which is really cool. Yeah, I mean, again, the possibilities are endless. There's a lot of stuff out there.
As you built this project out, what was the most surprising thing you learned?
Probably about, I don't know, like the whole math to figure out the positions and set angles of servos and stuff. It kind of blows my mind, especially when things get really complicated. It's probably kinematics, but also just the amount of setup I had to do on the Raspberry Pi to get PWM to work was kind of appalling. You had to do this, you had to basically set up this thing called Pi Blaster, but then they're like, oh, it already has like an apt-get repo that you can just pull from. And then I was like, sudo apt-get, and then it was like, it doesn't exist. And I was like, oh, okay. And it was like, you could compile this from source. And I was like, I guess that's what I'm doing. So I thought that was surprising. But, you know, doing laser cutting stuff was cool. I definitely burnt one really bad first. And then, yeah.
How many analog pins
Do I need?
how many servos are on there?
Oh, so there are 4 servos right now. I'm using 4 pins, and then also the LED that's run by a GPIO. So I can turn it on and off, and that's actually running off the 3.3 volts. But the servos are 4 pins that are on software PWM that, and then they're powered externally by the battery pack, which is giving 6 volts. So right now I'm only using 5 pins, but I think the Arduino or the Raspberry Pi has about 40 pins.
Because I don't want one big one. So
Yeah, there's a really good diagram that I was playing around with that had like a graphical layout of all the Raspberry Pi pins. But yeah, you're right. There are some that do or kind of like specialize in certain things.
Beaglebone does have more hardware PWM?
Which?
The Beaglebone?
The Beaglebone has twice as much.
Oh, are you on a Pi or on a Beaglebone?
I'm on a Pi.
Oh.
I couldn't get the Beaglebone one to, well, I could have if I like modified a lot of their node modules for the version of Debian that I was using, but I don't want to do that. Probably next week.
So this is Raspberry, and who's providing the Wi-Fi access point?
Me.
On the Raspberry?
Oh, so the Raspberry Pi comes with Bluetooth and Wi-Fi. Yeah, it's a Raspberry Pi 3. Yeah, and that has display, ribbon, camera, audio, HDMI, 1 gig of RAM, crazy. Quad cores running 64-bit Linux. It's just try to run that on your Commodore. Yeah, it's cool.
Cool.
Yeah. Well, thanks again, guys. Anybody else? Yeah.
Thanks for having me.
Thank you.